So this is like before where I'm going to have to figure out mole fraction using information in the chart, and then I can use the simple equation. So this one, it's still 100 grams of water, but this one has a different temperature. So more will dissolve. So that's going to change the mole fraction. And then notice, because the temperature is different, we're a lot closer to boiling, this value is a whole lot higher. So we will go up to, it says 95. So if this is 90, then maybe around in here would be 95. So I'm going to take this on up to the KNO3. And again, it's slightly over from where I want it to be, but it's what it's given me here. So then I'm going to kind of try to accommodate that. I'm going to try it one more time. So I'm going to go a little higher and then go over. And again, I feel like that number is slightly low because I feel like my line's slightly over, but it's close. And then this value right here in the middle, that is going to be 240. So half of that is going to be 230. So if you pick a number that's, 225, I might have picked like 224 or something because it seems a little bit lower than maybe half, then your answer should be in the right range. So we're going to go 224 grams of KBR. And then we're going to say that this is from the earlier problem. This information is given in 1 mole of KBR. That'll get me my moles of KBR, but remember I'm doing mole fraction, and so that's part of the bottom part of the equation. And remember it's solvent. So solvent here is water, so we're going to take 100 grams of water, 100.0. And then we're going to say in 100.0 grams of water, it's 18.02 grams of water in 1 mole. And then I'm going to copy that down to here. That's going to be my mole fraction. And then I already know my pure is 634 millimeters mercury. And again, I should be expecting a number less than that. I'm multiplying times a fraction that's less than 1. So it should be. So I'm going to bring this down over here. Whoa, I copied itself. Make sure I just get this part. So it's times that. And this is one nice thing about keeping numbers in your calculator. If you have problems that are related, especially like on the homework, that'll be more likely to happen. So I still have all these numbers in my calculator from the last one, but I can go up here, and of course this depends on your insert key and like how cooperative your calculator is going to be. It might be faster just to type it all in. But I've got 634 millimeters of mercury, and then I still have my waters on top, and the only thing that changed is right there. That's now 220, and I'm going to have to insert my 224, but then the rest of that's all the same. So using that second function, the way I did that on this calculator is, let me push enter, is second at the very bottom. You can see my word enter. Just above that is entry. That's where it gives you the formula. And then just to the left on my calculator, ANS, that's where it'll just use the answer. It'll repeat the answer down. But anyways, the vapor pressure of this is going to be 440 millimeters of mercury, which makes sense that it is lower and that it's higher than the previous problem, but it's lower vapor pressure than the pure.